All right, so hi everyone. As you said, my name is Pascal, and so I've spent the last few months reading the Angular 2 source code, and today I would like to share some learnings with you, and especially about dependency injection for future generations. So I took the topic dependency injection because of a couple of reasons. I think that dependency injection is important, or at least it's a nice pattern to write better code. And in addition to that, I think that the Angular team has done a very, very good job on the new dependency injection system. Before I start, a couple of things. So first, I want to thank two persons. Marek Christensen from Salt Lake City, he gave a great talk on dependency injection at NG Vegas just a few weeks ago. And he basically allowed me to steal some ideas for my talk. And then there's also Wojciech Gina, who's a former core member of the Angular team, and he gave a talk about the new dependency injection system last year at JSConf, which is what everything in this talk is basically based on. He made the original version. What you see today will be like the latest and greatest, and I hope you like it. Right, and then there's another thing. It has nothing to do with the talk at all, but I think it's fun to share. So just recently, I bought some new sunglasses and a soap bubble gun and a selfie stick. And so you might ask yourself, so why is this guy telling us about his latest achievements in online shopping? So the reason for that is that it didn't take long for me to realize that you can do some very, very fun stuff with it, and this is what I did. So basically, it's me running around randomly in the office with my selfie stick and shooting with soap bubbles at my colleagues. But yeah, let's talk some business. All right, so dependency injection. So I talked with some people here at the conference, and so they came to me and they asked me, yeah, so you're giving a talk here, right? And I was like, yeah, and they were like, okay, so what are you talking about? And I was like, yeah, dependency injection. And they were like, okay, so what are you talking about then? So there's not so much to say about it. And it turned out that, in fact, about dependency injection itself, there's not so super much to tell about, but again, there will be much more, especially in terms of the Angular 2 dependency injection system. So, nonetheless, here is my talk basically in a single slide. Dependency injection is a $25 term for a 5-cent concept. And that's sort of true, actually. So this guy right here, this is Wojta, one of the ones that I mentioned at the beginning of the talk. And this is where he gave his talk at JSConf about dependency injection. And so he said that we can see dependency injection basically as first as a design pattern, and we can also see it as a framework, and we have to distinguish between those two things. And this is what I would like to do today as well. I would like to show you the pattern itself, so that we all know what dependency injection actually is, the 5-cent concept. And then we talk about the dependency injection system or the framework. So, DI as a design pattern, or also known as the 5-cent concept. Let's start with this class right here. So this is an ES6 class. It's a car, and it has a constructor, and there's some stuff going on. It has a method drive to actually drive. And in the constructor, we can see that there are basically 3 dependencies, right? We have an engine, we have tires, and we have doors in order to create our car. And so despite the fact that we now have 3 different ways to create objects at that particular point, it turns out that this is actually not a good thing to do it like that. We have some problems with that code. And the problem that we have is that, so the car itself knows how to create an engine, and the car itself knows how to get tires and doors. And this can be a problem if you want to test your code, and as we all know, we love testing, and we just do it every day. We want to be able to write tests for this particular class without too much effort. Like just think about switching or swapping out those dependencies with mocks, right? It's pretty hard to do. So what we need is a way to kind of abstract those implementation details away so that the car doesn't know about it, right? And this is what it looks like. So basically what we do is we pass in the dependencies that we have in the constructor. So now the car needs an engine, it needs tires, and it needs doors in order to be created. And this makes the code much more testable, right? Because now when we create a car, we are able to inject our dependencies from the outside world, and the car itself doesn't know how to create those objects. And this is especially important when we run tests. For each test, we want to create a different environment, right? Like when you write a test spec, you have different scenarios that you want to represent in your spec, and therefore you need to be able to create objects in different scenarios and in circumstances. So in the end, you can say that testing and reusable code is somewhat like the same thing, right? And this kind of construction that we see here is also called constructor injection. And what we can do now is we can create our car like this, right? We pass in our 3 dependencies, and if we write a test, we can do it like that. And yay, our code is now testable, which is cool. And basically, that's it. That's dependency injection. Okay, there's another problem, though, that we have now, which is this guy here. We now have a main method. We now have to kind of wire all of our dependencies together manually ourselves in order to create a car object, right? So here we see all dependencies, and then we get our car. So in this case, it's just a very, very small application, but just imagine you have like a lot of classes and components and whatever. This can get very, very hairy. Like just think about adding just another dependency, right? So you have to really maintain it on each and every single object. So wouldn't it be nice if we had a system for that, or a kind of service that takes care of wiring everything together when we ask for a specific object? And this is basically where dependency injection as a framework comes in. So first, we just talked about the design pattern itself, but now we need a solution that makes the maintainability actually good. So getting back to our main method, what we want to do, or what would be very nice, is if we could do something like this. So we create an ejector wherever it comes from. It's just a very abstract kind of code. And we ask the injector to get a car, like an instance of car. And then we can use the car in order to work with that. Now, the injector knows how to create a car. And if the car has dependencies, then the injector also takes care of instantiating those dependencies. Otherwise, the car cannot be created. But you see that all the wiring is not there anymore. The injector takes care of that. So it turns out that in Angular 1, for example, we have that kind of system already. So here we have our car class. And in order to tell the injector what other dependencies are needed in order to create such an object, we have to annotate our code. And this is where the $inject property of a class comes in, right? This is one way of annotating our code in Angular 1 in order to tell the injector, hey, if you create an object of this class or of this service, you also need to create dependencies or other objects from those classes. So, and once we've done that, we could do something like this. So what we see here is an Angular module that is created, and we register our car as a car service. So basically what happens here is we say, okay, when somebody asks for car, that person gets an instance of the car service. So, and then we have another service that actually asks for car. And what you see here is another way of asking for an object without actually annotating the service itself. So here, Angular actually finds out, or is smart enough to find out what dependency you actually need based on the parameter name, which is car in that case. Which, of course, is a problem when you minify your code, and in that case, you want to use some kind of annotation like $inject. Okay, this is all cool. The dependency injection system works very well, but we still have some problems. So first, we have an internal cache in the injector. So whenever we get an object from a specific service, it's always a singleton. So if you ask for a car service, then you get an instance of car service, and if you ask for a car service at another place, you get the exact same instance back, which is something we probably don't want. Maybe we want to get a different instance whenever we ask for a specific object. Another problem is that this dependency injection system is synchronous by default, so we're not able to inject dependencies that are asynchronously resolved. And we have namespace collisions. There's no thing like a real namespace system. So when you create a service with the name car, and there's a third-party extension, Angular extension, that also introduces a service car, then the last one wins, right? It basically overrides your service. So it's not really able to have two different services with the same token in one application. Right. And then, last but not least, it's built right into the framework. The DI system of Angular 1 is not a system that we can use in any other code. If you write React or Ember or whatever, there's nothing you can do. You either take the whole framework or nothing. Which brings us to the next animated GIF, taking DI to the next level. Is anybody into Dragon Ball? I really like that one. Okay. So DI in Angular 2. Before we take a look at code of the new DI system, let's first understand the concepts of the new DI system. So in Angular 2, the dependency injection system has, of course, an injector, right? This is something that we want to have. We want to have a service that we can ask for object creation. And then, of course, what an injector does is it creates an object. This is what dependency injection in the end is all about, object creation. So now the big question is, how do we get there? Like, how does the injector know how to instantiate a particular object? When we ask for a service, how does the injector know how to create that object? In Angular 1, we have things like .service, .factory, .value, .whatever. In Angular 2 and the dependency injection system, we get something that is called a binding. So a binding is basically an instruction that tells the injector how to create an object of a certain token, right? So you can see a binding as a sort of recipe how to create an object. And it takes a token, whatever a token is, we'll get to that in a second, and based on that token, it creates, or the injector creates that object, but the binding instruction knows how to create an object of a certain dependency based on a token. Okay, so what does that actually look like in code? This is what it looks like in code. So what you see here is we are injecting a class injector from the Angular DI source code. And this might change in the future, so don't spend too much energy on the first line. It's just some way of getting that particular class. And then we're creating an injector with the method resolve and create. And resolve and create is basically a sort of factory function that lets us create injector instances, like different injector services that we need. And the resolve and create function gets a list of bindings. So you see that this list here is basically just a list of the classes that we need as dependencies. So you might wonder, how can classes just be like real bindings? Because they're just classes, right? We get into that in a minute. What we want to focus on now is, how does the injector know how to create a car when we ask for a car? And if the car has dependencies, how does the injector know which dependencies actually to resolve? Of course, we're passing in all the dependencies in our factory function right here that we need in our entire application, but it doesn't tell the injector which dependencies are needed for this particular car service. So if we take a look at our car class, it's exactly the same code. We again need something like annotation. Our class needs to know what dependencies are needed in order to create an object of it. And this is where this comes in. So what we do here, we inject something from the DI system. It's called inject. And then we extend the constructor with those weird guys here. And you might wonder, what the hell is that? So basically what happens here is, it's the metadata information that tells the injector that the first parameter of that constructor is an instance of the type engine. And the second one is tires, and the third one is doors. And the type here is actually also a token at the same time. But how is it possible that we can use inject with this @ sign? So what you see here is something that is called decorators. And decorators is a proposal for ES7, so it's really like something that eventually will be standardized. And decorators allow us to, like the name says, to decorate existing objects with additional information. And the reason that we are able to write the code like this and make it run is only because we can use transpilers today, right? So there are two transpilers that actually support decorators, and those are Babel and TypeScript. So a decorator, in the end, is just a function, right? The @ sign that we use is just part of the syntax, but in the end, the decorator itself is just a function. So what we see here is a very, very simplified implementation of what the inject decorator does. It takes some dependencies, and it has access to the target, which in our case is the car class. And then it adds some parameters on that class. That's all it does. So basically what happens is we call inject with engine on the car instance, or on the car class. So what that means is, if we take a look at that code, and we transpile that to ES5, what we get is something like that. Right? A class in ES6, in the end, is just a function in ES5. And parameters is just a property on that particular function. And then we have an array of parameters. And you see that each parameter currently is also an array itself. That's just because if you have more than one annotation or decorator for a single parameter, those are listed up in each array. So in the end, what this decorator does, it really just adds metadata to that particular class. And the injection system is able to read out that data in order to find out which other dependencies need to be instantiated in order to create a car object. Does that make sense? Okay, everybody goes like this so we can move on. So, but let's get back to the bindings. What is happening here? So we just pass in a list of classes, and those are supposed to be bindings. So it turns out that those classes here, as we write them there, is actually, it's part of a kind of shorthand syntax. It's like an implicit syntax of defining bindings. We can write the explicit version of it, and it would look something like this. So we import a function bind from the DI system, and then this is what happens. We say, okay, we create an injector with the following bindings. We bind the token car to the class car, and we do the same for the engine, for the tires, and for the doors. So basically what we're seeing here, what we're passing to bind is a token, and a token can be a type, which in the end is a class, or a string. And we bind it to another class. And the classes are here. So you might wonder, why do we want to do that? Actually, this is something you probably won't do because you can just use the shorthand syntax. But what this allows us to do is something like this. Bind engine to class other engine. Boom. So I show once again. We bind the token engine to another class other engine. What does that mean? So it enables us basically to do three things. First, we are able to map a token that is used across our application to any class, doesn't matter. So if you have an application with 10 classes and they all ask for something like engine, they will get an instance of other engine. If you want to swap out that dependency, you can just do it there. You just bind it to another class. And there are no name conflicts anymore, because other engine in that case is also just a type or a class, or maybe just another variable that is that has the value of another class. So if you're using if you're using a dependency that is called engine, and you have a third-party library or extension that also introduces a service engine, then this is the way how you can actually map both dependencies into your application without any name collision. Right, and this is actually not all. We can do more. So there are more binding instructions. Next to toClass, we also have something like toValue, which actually lets us bind a token to some value. So what happens here is we bind string to the string hello world. So if you have a class that has a dependency of type string, what you get is hello world as a string, which is amazing, because you can do something like configurations with that are injectable. We have toAlias, which basically maps a token to yet another token, right? So if you have an engine and you would rather name it V8 for whatever reason, you can create an alias for that particular token that binds to a class engine, which is super powerful. And of course, we have factories. So in some cases, you might need something like that, where you have a function that actually finds out which dependency you actually want to instantiate. So whenever somebody asks for an object that is of type engine, what you get back is either a V8 engine or V6 engine, depending on what the condition evaluates to. And of course, the factory itself can have their own dependencies, which is, so you can introduce them just with a second parameter here. It's just a list of another list of tokens that your injector's already configured, and then you can use those in your factory. And I think this is actually pretty cool, because it's like super powerful. It basically solves all our problems that we have with the DI system in Angular 1 right now. So there's still one thing that we haven't talked about yet, which is asynchronicity. So what are we doing with that? It turns out that the new DI system introduces yet another binding instruction, which is called toAsync factory. And what toAsync factory allows us to do is basically we can create a promise, and the promise will eventually resolve or reject depending on whatever happens inside that code. And then it will return that promise, and whenever we ask for something like engine in that case, we get an engine promise, which eventually will be resolved. So here, we return a promise, we fetch some engine data, and when the data comes back, we actually create a new instance of engine with that data, right? But still, in your application code, you just ask for something of type engine. This leads to more decorators, because all of a sudden, we have two strategies. We can inject dependencies synchronous or asynchronous, which means we need a new decorator that tells our application or our injector that some parameters are actually injected asynchronously. So what we can do is we use inject promise as a decorator. So what it does is it basically tells the injector, okay, so this is the token engine, and the injection system then finds out, okay, so it's the token that is bound to the async factory, so it returns a promise. So what we get is an engine promise. And then later in our constructor, we can use that promise in order to react on some stuff, depending on what the promise does. There's another thing called inject lazy, and inject lazy basically gives you the factory function that the injector itself uses in order to create a dependency. So in this case, you can create an engine only if you really need it. And we also have optional dependencies. So a decorator optional, and this is, by the way, the first time you see more than one decorator and one parameter. And so what happens here is we're injecting an engine which is optional, and if there's no engine in the system, then it will return null. It can be very helpful if you have something like that let's say your class expects something like jQuery or something, and it's just optional, then it allows you to create a fallback or ask for a fallback. So the following problems are now solved in this DI system, which are, so we have asynchronous and synchronous strategies. We have no namespace conflicts anymore because of the binding instructions. It can be used standalone. Whatever you see right here is a framework agnostic system, right? I actually saw people using that with React, which I think is awesome. But there's still one thing. Dependencies are served as singletons. So it turns out that the new DI system still returns singletons. So how do we handle that? There's a concept that is called transient dependencies. And what that means is we can create child injectors in our application in order to override some bindings, or in order to get different instances of a specific class. So what does it look like? Here we have the same code. We create an injector with a binding engine, which is, as we know, bind engine to class engine. And we create a child injector that gets the same binding. But if we ask both injectors for that type, we get different instances, right? So this is one thing. The other thing is that when we create a child injector and we have a parent injector that has more than just an engine binding, and we ask the child injector for a binding that is actually not configured in the child injector, then those bindings are looked up in the parent injector. It sounds super confusing. That's why I have this awesome graphic here that I, by the way, stole from Merrick. So we create a parent injector with 4 bindings, car, engine, and tires, and doors. And we create a child injector with car and engine, and we create another child injector with just car. So what happens if we now ask the second child injector for a service car? What we get is the car object created by the child injector, but there's no engine binding configured in that child injector, so it looks it up in the parent injector, and so on and so forth. So it's a kind of prototypical inheritance what's happening here. You're not impressed. So when I saw that the first time, I was like, wow, that's awesome and super flexible and everything. But yeah, so how is it used in Angular 2 then? So I don't know if you've seen any Angular 2 code yet. You probably did. This is what a component in Angular 2 looks like. So we have a class, in this case, just has a constructor that sets a name property, nothing special here. And then we have 2 more decorators, also known as annotations. And the component decorator basically tells Angular, hey, this particular class is a component. And the view annotation tells Angular, this view configuration is the view for this component. Nothing super special about it. And then we just need to bootstrap that application. Bootstrap is a function that we also need to import from the Angular source code, from the framework. So this is how you create your first Angular 2 application. Super simple. So what happens if we want to inject a service? So we create a service, name service. It does nothing special. It sets a name property, and it has a method to get the name. And what we do then is we pass that service to that bootstrap function. And this is basically the resolve and create part, right? So you pass in a binding. What you're allowed to do is you can also use the bind syntax here. So it's, again, just the shorthand syntax in order to make the name service available across your entire application. And then in your component, what you need to do is you just inject that name service of the type name service and get an instance of that. If you're into TypeScript, you can just use TypeScript like that. So you add type annotations, and it works the same way. What is interesting here is you don't have any decorator machinery here anymore, right? So this is just plain TypeScript code, and it works out of the box. There's another thing. You might want to use child injectors in order to create a different binding for a name service in a particular component, and this is where the injectables property of the component comes in. So if you've seen that, what it basically does is it just configures new bindings for that particular component. It's basically a child injector that is created at that point. Okay, so we learned that the DI system, the new DI system in Angular 2, solves all the problem of Angular 1. And it's super flexible. It is synchronous and asynchronous, and you can use it with your code because it's framework agnostic, which is awesome. And that's all I have. Thank you very much.
Well, there are a lot of questions, so we're going to be sitting here for a while. No coffee for you.
Uh-oh.
Uh-oh.
Please ask questions that I can actually answer. Thank you.
They're only hard questions. I don't know how we are going to manage. Okay, so the first one is, can you explain the difference between the dependency injection pattern and the factory pattern?
The dependency injection pattern and the factory pattern. In Angular 1, or is it a question from Twitter?
Yes.
Okay, then it's probably a bit hard to ask. So the factory pattern as a design pattern itself, it's just a pattern that creates an instance of an object, but it has nothing to do with dependency injection per se. It's just a way of creating objects. So what you can do is, instead of doing something like var car equals new car, so you're calling the constructor directly, what you can do is you can have a car factory that gives you a car. So you basically abstract the concrete implementation away, which is good, but it has nothing to do with dependency injection. So it's not really a versus R question, I guess.
So the next one is pretty great. If you should convince people about static typing in JavaScript, what would you say? You can do it in dramatic voice.
So I like TypeScript, that's my answer.
Fair enough, I think that's acceptable. Can you explain the benefits of the DI framework over a more traditional AMD loading approach?
Okay, so that's a good question. I think we need to distinguish here. AMD is a module system that allows you to load modules in ES5 today, right? You can do it with CommonJS or System.js or AMD or whatever you want to do. Dependency injection is on a different layer. It doesn't solve the problem of loading modules, right? So what you've seen in the code was we used ES6 and ES6 modules, but the dependency injection basically has nothing to do with it. So there are two different things, loading modules and dependency injection.
Okay, two more, which are kind of connected. How async dependency injection works after minification, and will async dependencies allow generators as well?
That's a good question. So the minification actually is decoupled from whatever binding instruction you use. So the nice thing that we have with the new dependency injection system is we can use string tokens, but we don't have to. So if you just do something like bind car to class car, there's no string, and minification just works, right? And you cannot minify strings, so that's actually better. I'm actually not sure how the generator support will be in the asynchronous dependency injection.
There are just so many questions. I think we're going to sit here forever, seriously. Well, we have a couple more minutes, so might as well.
Oh, wow.
Can we inject objects into functions instead of class constructors?
Oh, good question. Again, a class is just a function. So if you transpile a class in ES6 to ES5, it will be just a constructor function. So the answer is yes. In the end, you can use that system in ES5 and just write functions. It's the same stuff. It's just that that one slide where we saw what the decorator does to that class when we transpile it. So the answer is yes.
For the rest of the conference, we're just going to have this interview, basically. Just bring food, okay, and coffee. Thank you. Okay, two more, because I guess they'll be quick. Is there a way to destroy cleanup injectors?
To what? Sorry?
Is there a way to destroy / cleanup injectors?
Ah, okay. No. I mean, it's just an object. So same rules apply to the injector as to every object in JavaScript.
Okay, last question. How can we handle code modification? Do we have an inject variable in Angular 2 as well?
Right, so I think that question I already answered with the other answer.
That's what I thought. Just
right, so
sure.
minification just works, it's just code. If you don't use strings, then it's even better, and you can do that with the new dependency injection system. So, yeah.
Okay, maybe one question from the audience, if there is one. Or everyone was using Twitter. Oh,
I have a question, actually.
To yourself? Okay.
No, to you guys. Are you actually excited about that stuff? I was super excited when I learned about it, but you were like, oh, well. Okay.
Hello. In the return about...
Where? Over there.
Here.
Hi there.
Here. In return about asynchronous AMD CommonJS, they solve the same problem as the dependency, also and models loading models. Why we should use something else if we have CommonJS that solves the same problem?
So I think it's not really exactly the same problem. Like when you use something like AMD or CommonJS, it's still just a way to load a module or to load a dependency. But you still at some point have a sort of main function that you need to maintain in order to create objects. Of course, it depends on your code and on your use case. But as I said, so you have module loading, which is one thing. And you have dependency injection, which is really just a way of creating objects and passing them into constructors, which you maybe want to abstract away, which you can do with that system. So I think those are two different things.
Okay.
That's my opinion, at least.
Okay.
Okay, since we could actually sit here forever from what I'm saying, like hand-wise and Twitter-wise, and I think everyone wants coffee, and also we have another talk upcoming after the break. We're going to break it off, but worry not, Pascal's still here. You can catch him and ask all the questions. He might get or not get annoyed.
I also have stickers, by the way, if you're interested in stickers.
So if you have any more questions for Pascal, as I'm sure you do, just catch him during the break or during lunch, but let the guy eat first, please. Thank you so much. That was amazing.
Thank you very much.